All right. So we just heard from Dan. Figure now we'll switch things up and talk about CircleCI and AWS so that we can get happy deployments. So if you want to follow along with these slides, they're online because I'm using Dan's computer here. So you can go to v.gd/CircleCI AWS if you want the slides as well. So you don't have to take notes or scratch things down. So a little bit about myself. My name is Russell Heimlich. Yes, Heimlich, like the maneuver. I like building website stuff. I'm currently the lead developer at a company called Spirited Media. We're a local news startup with newsrooms in Philadelphia, Pittsburgh, and Denver. And one of the things we do at Spirited Media is we build software, right? I'm sure many people in this room also build software as well. And it doesn't help to just build software. We need to get that software to other places, whether that be different environments like production or staging or even other developers' local machines. But we also don't really want to break things, so we need a way that helps prevent that from happening. And so that's where continuous integration and continuous deployment comes in. It lets us create a workflow that happens automatically in an automated way, something that's predictable, and mainly it'll help stop if something breaks, so it won't continue to go through and deploy code that's going to break something. So when I started at Spirited Media, they had a deployment checklist that they did. It was manual. You had to click on different things. You had to log into a dashboard. And one of the last steps in it was a reminder to breathe, which is kind of scary because it's like, well, we're deploying code. We're going to do this a lot. We don't want a deployment process that's going to give us anxiety, right? Deployment should be very boring. It should happen automatically. It should do everything we expect it to do and not break things. So a good deployment that's boring allows us to release features faster because we don't have to worry about if something's going to break. So enter a product that's called CircleCI. So when I started revamping how we did things when I got there, we ended up going with CircleCI. So what does CircleCI do? Well, it basically just listens for changes to a GitHub or a Bitbucket repo, and then it does the stuff we tell it to do. It's really easy to sign up. You can just go there and authenticate with your GitHub or Bitbucket. It automatically, brings you in and you give it access to your repos. It sets up the webhooks and all that stuff. It's like one click and you're there. So once you do that and you give it access, the next thing is you need to tell CircleCI what to do. And to do that, we use a config.yaml file at the root of our project, so it's version controlled. So whenever I have to do YAML, this is kind of what my setup that I use, is to use a straight edge ruler for all the space indenting. First, we should clarify some jargon that they use. They have steps in a build process in CircleCI are called jobs, and then one or more jobs make up what's called a workflow. And so workflows that you can run them sequentially or in parallel, so you can do things like fanning out and fanning in. So you can, like Dan mentioned, you can split your logic and your tests. So you can run a couple of steps or a couple of jobs in your workflow, and then you can break it out into running all your tests at once concurrently. And then when those are all done, it does other types of tests in this diagram. Our build process at Spirited Media is really straightforward. It can be done in a parallel fashion. We basically set up the build environment, download any dependencies that we might be using. We compile static assets like Sass into CSS, and we minify JavaScript files and stuff like that. And we lint our files to make sure they conform to our coding standards. And if any of those steps should fail, well, then the build stops and it doesn't deploy the code, and it lets us know that, hey, this build is wrong. There's something broken about it. So this is kind of a diagram of our workflow here. We have this code repo down at the bottom where we author stuff, and then CircleCI monitors that repo. Any changes that happen, then CircleCI gets kicked off and does its thing. If the code changes need to actually be deployed somewhere, we'll actually commit those changes to a build-specific repo. And then we have AWS CodePipeline, which monitors that repo. And then when that happens, it kicks off AWS CodeDeploy, which actually goes out to all our servers and says, hey, there's a new code deployment. Go download all these files, right? So that's kind of, keep that in mind as we go through the steps here. That's kind of what we're going for. So a walkthrough of our config.yaml file. First, it starts with a version at the top. They used to have version 1, and they made everyone upgrade because they sunsetted version 1, so we had to kind of redo everything. But The most basic thing that you do is you define your Docker image that you're going to use during the build process. CircleCI has a whole bunch of different Docker images that you can use they're just ready to go, and you can configure that. Next up, you define your jobs. This one's called build, as indicated here. And then after that, you kind of lay out the steps that are part of that job, and you reference your Docker image there. So you can actually have different Docker images for different build steps if you wanted, or you can mix it up that way. So the first step is it checks out the code and downloads it onto our build server. After that, they have caching, so we can restore a cache from a previous build of files that have already been compiled. So for example, if you're downloading assets or dependencies, you can just download them, from a previous state as opposed to downloading them from scratch, which saves a lot of time. Because especially like your node modules directory can be really huge, and it would take a long time to download those dependencies over and over and over again with each build. So you can restore the cache, and you name them based on when the lock file of your dependencies change, it'll also automatically flush the cache at the same time. Our build image had an old version of Yarn. We remove it. We install a new version of Yarn. We install Grunt, which is a task runner that we use to actually build stuff, to minify CSS and JavaScript and stuff. So we set all that stuff up so that we can actually do our build. And we just, we run our dependencies to download the latest version of our dependencies again to make sure our cache is up to date. And then once that happens, we save our cache again. So the next time we need to run this exact same build, it's already there. It saves a lot of time. So now we actually get to the part where we're actually doing the build. And in here, we just run, it's basically like a shell script where we have some logic that says, hey, if this is the staging branch, our test branch, then just run grunt. Otherwise, we're going to run grunt build. So grunt build is just more precise. It does more stricter linting checks. If it's on the staging branch, we need things like source maps and stuff like that. So we can configure the build for which environment it's going to. And at the end, maybe we're going to need to deploy this, so we can set up some logic that if the branch is staging, then we're going to run our deploy script, and if it's a tagged release, then we're also going to run our deploy script. But everything else, we would stop after this. We wouldn't bother with this step. And there's all kinds of, CircleCI gives you all types of environment variables to play with, so you can check the name of the branch, the tag, the committer, the build number, all kinds of stuff that you can use, when you're working out your continuous integration pipeline. So once your job is kind of set up, the next thing is to put it into a workflow. This is also at the bottom of the file. We named our workflow here build and deploy right here. And we list the steps as jobs there. And one of the cool things is you can actually tell it which branches should ignore or which you should use. So in this case, we'll run our build on every branch unless the branch is master. And we'll also run it only on, if it's a tagged release, we'll only run it if it matches the pattern of like v0.0.0 of a certain semantic version of it. So if there was another tag that got pushed, it wouldn't run a build for it. And so this is kind of what the interface looks like. It's pretty similar to what Jenkins is that Dan showed. Each of our steps that we laid out in our YAML file are displayed as steps here in the interface, and you can twirl them down and see all the output of the code there, and you get timings and stuff like that. So when it comes time to actually deploy, we want to be able to get our code changes out to different servers and environments as fast as possible. We don't want to download every single file. We just want to download the changes of them. And so a great way to do that is to actually use Git, because Git is just basically a series of just changes. So this is kind of a walkthrough of what our deploy script looks like. So we just do some basic setup, and we set our Git username to the CircleCI so we know that it came from our build process. We actually construct a brand new README file for each build that we do. And so we put in some meta information about it. When it gets rendered out, it kind of looks like this. Gives us a build number, a compare link, a link back to CircleCI. So it's nice that while you're testing this and working on it to make sure it works, you can just go to GitHub and you could look at the README and instantly see when the last time the code was built. We get a little bit fancier for when we're actually deploying to production. We'll actually parse the Git log, and we'll construct a change log from it based on pull requests in there. The details of how to do that are in the link there. They're in a gist. So some other things we do is when we're deploying to production, we don't want to deploy code that we don't actually need, like a really big node modules directory. So we make sure to explicitly remove that. We get rid of any of our Git directories that are in our code base and any Git ignore files. So when we actually do this build, we actually have a specific Git ignore file for the build. So we swap that in. And the next step is to kind of bring in our build repo, and we're going to we clone that repo down and move the Git directory back up one level, so that and then we set what branch it's at. So we assume that it's master if it's not set, but then we make sure that the branch that we're building has an equal branch in the build repo. So we just check that out and make sure that those things are there. And then finally, we just add everything. We make a commit message and we push it up to GitHub. So we do a force push of all the changes, so that once the build server, everything that's on the build server as it is, we just push those changes back up to Git. And then so this is kind of what it looks like in Git. All of our commits are just separate builds. So if we needed to revert, we could just go back a commit or two, or to any certain version. And then we have all the information in the commit message of when it was built and by who and all that kind of stuff. So now that we have our code ready to go, we can take that code, check it out on any server, and it should be able to just run. So how do we actually get this to our different servers? And for that, we use AWS CodePipeline, which basically acts as the glue between GitHub and CodeDeploy. It's pretty simple to set up. You just tell it, hey, watch this GitHub repo, and when something changes, then run this AWS CodeDeploy service. That's really all it does, just from one thing to the other. So AWS CodeDeploy is what actually talks to our servers and tells them that they need to go and update their code. It does require you to install the AWS CodeDeploy agent on your EC2 instances, but there's instructions on how to do that and get that set up and working. And so in AWS CodeDeploy, you can do things, this is the console to configure it. You can give it a name. You set up a service role to tell it what it has access to and what it doesn't. There's different types of deployments you could do. So you could do an in-place deployment where the server stays alive and then you tell it to update some code. Or you could do a blue-green deployment where you spin up new servers and put the code on it and then take away the old servers. Ours is pretty straightforward. We just do in-place. And then in order for CodeDeploy to know which servers it needs to deploy to, we do it based on tags. So any EC2 instance that has the environment tag of production is going to get updated. You can do things like deploying one at a time, half at a time, all at once. So we like to deploy all at once. We haven't found any issues with that, but you could do it one at a time or be more careful if you wanted to. And finally, in the advanced option, you could set up triggers. So you could set up notifications like to Slack or email or anything that AWS does. So CodeDeploy also is configured by a YAML file called an appspec.yaml file. So we got to get out our trusty side rule again. And it's pretty straightforward here. It's just this is the whole thing. There's different hooks that CodeDeploy uses, and so we just specify on this hook we're going to run this script, which is actually in our repo itself. If that script takes longer than 10 minutes, then it's considered a failure and it should roll back. And it runs as root. So this is kind of our CodeDeploy script. There's more comments than actual code, but the gist of it is what we want to do is we want to run a script that's already on our server, but this appsec YAML file doesn't let us just run an arbitrary script. So what we have to do is we actually have to make a request to this metadata at this IP address. So every EC2 instance, you can ping this IP address and get metadata about it. So we pull out a script that's in the user data field, and that script points to a script that's on the server, and then we take a script to generate a script, to run a script, to point to a script, to run a script, to deploy. So there's a lot of hoop jumping in order to get it to work, but basically when we set up our EC2 instances, we include that script just like that. We bake the deploy production shell script into the server itself. Right, so you can actually, and just like that little information bubble in the Amazon console says, you can specify user data to configure an instance or run a configuration script during launch, so why not also use that when you're deploying, right?
previous script, when you were sourcing your user data, where is it sourcing it from? Is it
This
from
script
the-
here, this var www.spiritedmedia.com script, that's already built into our server. So imagine we already have our servers running. The script's already living there.
Okay.
That makes sense.
Pre-existing.
It's pre-existing.
But this is user data,
This is user data.
which you use to bootstrap a brand new instance,
Sure.
which is not existing.
Oh, you're using a custom AMI, right?
So you're getting
This is a custom AMI. Yeah. Well, our servers are already up and running. They're not. They don't get destroyed very often.
Well, you're just using that to say what to run when CodeDeploy does an update.
Yeah.
Right.
Yeah.
Okay.
Yeah, I'm basically telling CodeDeploy, hey, run this script that's already in the user data that I'd already used to boot up the AMI. So like this thing here is just saying go out,
And get the user data.
yeah, and get the user data right and turn into a script and then run that script that runs this script. Yeah. So it's kind of weird you have to run these kind of hoops like that. It would be easier just to say run this script that's over here. I know it's there, but it doesn't let you do it.
Why not just pull it from S3 or something?
Why not just pull it from S3? You mean this?
Okay.
Just
Yeah, it's fine.
well, this is already here for when the AMI boots up, so I might as well reuse it again, right? I mean, it's already there. All right, cool. So this is our deploy to production script, like Dan does. It's just a lot of Bash scripts. Go to the root directory of our web server, do a git pull, do a hard git pull that we just clone from our build repo, and the code, all the changes will be there in the server, just like that. And then to be safe, we just make sure that the files are owned by the server, so that the server can read them. And then there's other stuff we do, like we flush stuff from CDNs, and we do some other app-specific stuff. But this is the main part of the deployment part.
So mostly what you're doing is running bash, on bash, on bash.
Yep.
So, have you found any concerns about limitation of variables within bash? Because I've done this with another consulting group, another company, not to be named.
Sure.
We ran out.
No, I haven't found any issues with that.
Want to see if you ever get there.
No.
Bash lengths of variables. In other words, we ran into it because of how complex the bash got. We ultimately had to change our methodology.
Sure. I can understand if you ran into it, something like that. I mean, ours are really simple. Like, it's literally just that.
Source your variable files and just split it up.
I mean, like a length or number or what?
Number of them.
See the environment size.
This is the way they wrote it. I didn't write it.
You're just the messenger.
I want to use it. I didn't write it.
So that's pretty much our deploy process. It's like we have an authoring repo that CircleCI will then build that gets committed to a build-specific repo that no humans actually touch. It's all robots. That CodePipeline listens to, that then tells CodeDeploy that it needs to do its thing, and it goes to the servers, and the servers just pull down that build repo and get our changes on the servers. So it's pretty quick.
Can I ask a question?
Yep.
So you're not doing this to like update this content, like the news content, right? You like self back
Yeah.
end.
It's all code, WordPress,
Okay.
stuff like that. Yeah,
Cool.
not content. Yeah.
Just to make sure.
Yeah.
Like, it seems like a lot of work to update an article. About
Oh yeah, that would be
baseball game or something.
that would be very tough.
What does code deploy kind of translate to in the open source world?
In the open source world, I don't know. Bash scripts. I mean, I don't know.
There's nothing like that.
I only do it because I have EC2 instances and it's there and they can talk to it, so I use it. Some tips and tricks that I found along the way. When you're setting this up, you probably want to use a separate GitHub user that's specific for deployment, and GitHub calls these machine users. Because what you don't want is to have someone in your organization whose credentials are tied to your build process, and then they leave, and then your build stops working. So it's good to just set up that extra user and then do all this stuff with that user to get everything set up. One of the neat things about CircleCI is that when you have a build that fails, you can rerun it and enable SSH access. So once the build fails again, then you can SSH back into that machine. You can poke around, you can make changes, you can do whatever. So it's really helpful for debugging stuff because you don't have to guess what's going on. You can actually go in there and look and see what happened. You could set up deployment notifications via Slack, right? So when our deployments happen, we send a message out to our Slack channel. CircleCI has a built-in integration so that whenever a build fails, it can send a Slack message. You can configure all that stuff. It's real helpful to know that, oh, guess what? A deployment's happening. I didn't even realize it. When you use AWS CodePipeline, it actually downloads the entire repo as a zip file to an S3 bucket. We don't actually use that, so we set up lifecycle rules on an S3 bucket so they don't pile up. So in terms of pricing, how much does all this cost? So CircleCI is very generous in that the first container is free and gives you 1,000 build minutes per month. For a small startup like us and for what we do, that's plenty. That translates to like 16 hours a month or something like that. The closest we ever got to getting to the limit was 12 hours 1 month. Because our builds are really quick. They're like 2 minutes, not like an hour. And after your, if you need more than that, you can spend $50 per month and get an additional container and get unlimited time on that. If you have an open source project, they'll give you 4 free containers to do whatever you want with, I guess. I don't know if that has any limits of minutes or anything like that. So then I guess the big question is, how does this compare to like AWS CodeBuild? AWS CodeBuild is Amazon's version of CircleCI that they launched later after I got everything set up and working. So they charge 5 cents or half a cent per build minute on their smallest tier. The first 100 minutes per month are free. So the magic question is, if your monthly build time is less than 168 hours, then it makes sense to use AWS CodeBuild from a financial perspective. If it's greater than 168 hours, it's probably better to use CircleCI. Assuming you use AWS CodeBuild makes sense, assuming you use less than 1,000 minutes or 16 hours a month, right? So some of the differences of CircleCI and AWS CodeBuild, from what I could tell, looking at documentation. So the pros of CircleCI is it has an awesome debugging experience with being able to SSH into a machine and debug what's going on. I think there's something with AWS CodeBuild where you can do it locally, but it sounds really complicated to set up. It's much easier to set up parallel jobs with CircleCI that you can easily branch into different and run concurrent ones if you have enough containers. And definitely the pricing, if you need 1,000 build minutes per month or less, then CircleCI makes a whole lot of sense. Some of the cons of CircleCI is that it gets expensive once you need to move past the free tier. Some of the pros of AWS CodeBuild is that, well, it's pay for what you use pricing. So if you needed to run a whole bunch of concurrent builds at one time, like once a month or something, it probably makes a lot more sense to do it with CodeBuild that way than to try to do it with CircleCI, where you're limited on the number of containers you can run. And the cost of AWS CodeBuild if you need to run more than 1,000 build minutes per month. And you can run as many concurrent builds as you need because it's on demand. Cons of AWS CodeBuild, it's breaking up one job into multiple concurrent parts is difficult. I read some things about using Lambda to trigger things and stuff like that, and it seems tricky. It's a little more work to set up because you have to integrate with some other services like CodePipeline to monitor your code repository, stuff like that. But there are some articles here for further reading if you're interested, talking about building a WordPress plugin using this multi-job workflow on CircleCI and serverless integration stuff, right? So kind of to wrap things up, this whole process kind of reminded me of this. I grew up in the 80s watching Domino Rally. It's kind of like you set all this stuff up and push a domino and hope it all kind of works out at the end. And it looks like so much fun in the commercial. When you actually do it, it's a lot of work. And then like, oh, look, they launched the rocket, right? So it's kind of continuous integration, continuous deployment. It's kind of like playing dominoes with YAML and shell scripts. But in the end, it's really awesome when it all works, and it just, you don't have to even think about it after that. So that's my presentation. Thank you.
It's more like dominoes that would actually set themselves back up again.
Well, they had that little machine that would go around and set it up for you.
Cool, thanks.
Any questions?
Yes. So along the lines of my last question, how often do you have to change a bunch of stuff on the back end?
Like the code stuff?
Yeah.
Well, I mean, we'll release new features, I don't know, like 4 or 5 times a week.
Oh,
You know, like a lot of times it's small stuff, but sometimes there's big features, and so the goal is that anyone should be able to deploy. You know, even our product manager who doesn't exactly know how to code stuff can go in there and make a change on GitHub, and once they push a release, you know, it kicks off and does everything it should do, right? Deploying shouldn't be scary. Yeah.
Do you have a way that you manage the fleet of servers themselves, like the AMIs they're using or anything like that? Like, are they a fleet? Like I saw on Amazon they have SSM fleet management. That's recent, but do you have any way you can do blue green WordPress upgrades or anything like that to each server?
Our setup isn't set up like our stack isn't set up like that, just because ours is really simple and it'd be a lot more work to make it work like that.
You're not talking about like hundreds of servers or anything.
We have 2.
I was thinking of that one.
Yeah, it's 2, but they can auto scale and grow and die whenever they need to and stuff like that. But so it would take more time to automate that than it would to just set it up. Yeah. So we have an AMI that we'll do maintenance stuff updates on, but we'll do that every couple of months as needed, kind of thing. So none of the fancy stuff like setting up a whole environment like what you do and tearing it down right away. So yeah.
So if you had to roll back, would you just push like the previous commit? Would that work? Or?
Yeah. So to roll back, we could have something that would go on the servers and revert back a previous commit, and it would all just go back to the state it was before. Yeah. But honestly, I've never had an instance where I had to roll back. It's usually easier just to fix whatever the problem is than it is to roll back, even though rolling back's pretty easy, if that makes sense.
So how does that SSH when you're debugging? What does that bring you into? Like the code build machine, the Docker instance, or?
It's that actual Docker instance.
Okay.
That actually failed, yeah.
Okay, so into a WordPress.
No. So what it does is tips and tricks. So you can see here, this is the actual message you get when it fails. You basically just copy. I changed the IP address to 1.1.1, but you copy that line and just put it in your terminal and just,
that's cool.
You know, it takes you right in there, and then you're at a command prompt, and you look around, and there's your code that you just checked out and everything. So it's pretty neat. Yep.
So does CircleCI have support for integrating with like a rolling deployment strategy or blue-green deployments where I'm going to take down one server at a time, deploy it, upgrade it, then put it back into service, and move on to the next one, so I'm always available?
Does CircleCI have that?
Yeah. Does that tools to support that, or you have to code all that up yourself?
Well, I mean, we use AWS CodeDeploy to actually talk to the AWS servers, but I don't know the integrations between CircleCI because we built ours ourselves to do what we needed to do.
I saw a checkbox at one point that said blue green deployment.
So yeah, so that was in CodeDeploy. So that's an AWS thing, like that.
Yeah.
So there's a box up here that says blue green. So you could have AWS do that stuff. So this is a service that Amazon runs that does it. So I don't think, to answer your question specifically, I don't think CircleCI has anything like that, but you know, you could always make AWS do it.
They don't really have the CD part of it, right?
I'm not entirely aware of, but they do have a lot of integrations and stuff. They've been working on that, I think, as a feature, is one click, like talk to AWS and have it do whatever it is you need to do. Okay. If that works for you. So stuff like Elastic Beanstalk probably is integrated, stuff like that. All right.
Any other questions?
Any other questions?
All right.
Thanks.
Thanks.
Again, everyone.
Go ahead and clap first.